Alright, welcome back to part 2 of the Trig video P.5 or Pre-Calc 1.4. Our first example talks about finding the domain of a function. So what I've done is I've shown the graph over here. So if we take a look at it, let's first understand what this graph is showing us. These vertical lines that you have here are the vertical asymptotes. That is the place where the graph does not exist. So this graph is set up to connect it. So that's why it's drawing those vertical lines there. So that's going to be a good indication of what x values do not work. And what I'm noticing is that it looks like I've got a number that's between -2 and -1. It looks like 0 is not working, and then another x value between +1 and +2. So it's not going right through at a nice whole number for us to be able to pull right off of the graph and say x equals all of these numbers except for maybe +2 or +3. So when that's the case, one of the concepts that you need to understand in order for this graph to exist is that if this problem was 10 over 0, it would become undefined. In other words, if my denominator was equal to 0. So that's what I want to do, is find out what values will make my denominator equal to 0. So I want to set the denominator equal to 0. So if I solve this equation, I've got to rely on my factoring skills to help me figure out what x is. So I take out a greatest common factor first. And then I set both parts equal to 0. And solving this, I'm going to end up with x squared equals 2. Get rid of the squared by taking the square root, and I would find that x would be equal to plus or minus the square root of 2. And I know that that is the same as 1.41 roughly. So I can confirm that the places where the graph does not exist, we're at 0 right here, about +1.4 and about -1.4. But again, the question says to find the domain. In other words, which x values work. So what I've done is I've listed the 3 values that don't work. So I'd want to write my domain is that x cannot equal 0 and x cannot equal the positive or negative square root of 2. So whenever you have a rational expression like this, you want to make sure that you understand that the denominator cannot be equal to 0 because this is where the graph does not exist. So set your denominator equal to 0, and that's going to give you the x values that will not work for this graph, and we can see that every other x value, all of these negative x values work up until -1.4, and then they're working up here in between -1.4 and 0, working again in between 0 and 1.4, and then everything that's greater than 1.4 is working as well. So I think looking at the graph is helpful, but we have to do the algebra to find these exact values of the square root of 2 and the negative square root of 2. So in our next example, this one is asking us to now figure out what value makes this equal to 0. So in other words, I want to plug in a 0 for f of x and solve this. So I've got to go back to my factoring techniques again. To factor this, I want to pull out the greatest common factor, which in this case they both have an x in common. So that would leave me with x times x squared minus 1. And again, I want to set both of these equal to 0. So I'll add 1 and then get rid of the squared by taking the square root. Remember, when I'm solving an equation with a squared root, with a squared in it, and I take the square root, I've got to consider both the positive and the negative options. Another thing to remember when you're solving these, whatever your highest exponent is, in this case if it's 3, when you set it equal to 0, you should get 3 zeros out of the answer because that's your highest exponent. a lot of times students will just write this as just x equals 1 and forget the plus or minus, so you want to make sure you include that when you are solving these problems. So when it says, when will this equation equal 0, you just have to set it equal to 0 to solve. Alright, the next concept in our notes that we're going to talk about is something called the difference quotient. And this is something that you're going to have a lot more exposure to in calculus class. What we're going to be talking about in here is just how you use the quotient, not necessarily what it's used for. We're just going to be talking about the algebra behind it to give you some exposure to that. So the ratio is this. Take f of x plus h, subtract f of x, and divide it by h. So what you're going to do is you're going to be plugging in if f of x is x squared minus 4x plus 7. First thing you're going to do is plug in an x plus h wherever you see an x. So take this equation, and wherever you see an x, here and here, plug in an x plus h. So that becomes x plus h squared minus 4 times x plus h, and then plus 7. So that's just giving you this portion of the formula. Then it says to subtract f of x. Well, all of this is f of x. So the next thing I'm going to do, change the colors here, is I'm going to subtract f of x. Make sure you put this subtraction in parentheses, so you're going to have to use a distributive property and not just write it like this. Because if you write it like this, you will forget to use the distributive property, and these will have the wrong sign values associated with them. And then finally, so we've done that part, finally you just divide by h then. So once I've got it set up, now I just do the algebra associated with it. X plus h squared, we have to FOIL that. We're going to get x squared. This is going to give me an xh. This also gives me another xh, so that makes 2 of those, 2xh. And then that makes an h squared. So this part is done. Now do the distributive property, and you would get negative 4x minus 4h. Drop down the plus 7. Distributive property again. Negative x squared, positive 4x, negative 7. And then we're going to divide all this still by h. If you've done the difference quotient correctly, you're going to get a lot of cancelization here. So let's make sure that we are getting things to cancel. So I've got an x squared and a negative x squared. I've got a 2xh. I don't have any more of those. So I've got to bring that down as part of my answer. Cross it off so you don't try to use it again. The next term is an h squared, and notice you don't have any more of those in the numerator. Cross it off. Then you have a negative 4x and a positive 4x. Cancels each other out. The next term is a negative 4h. There aren't any of those. So bring that down. And then you notice that the 7s are going to cancel each other out. So all of the terms here that don't cancel out, they should be the terms that have h's in them. If you're finding that any of these terms don't have that h in it, more than likely you did something wrong when you input it up here and did your algebra. So now what I'm going to be able to do is I can get an h to go out of all of these if I pull out the h as the greatest common factor. So I could rewrite my numerator as h times 2x plus h minus 4. And I get the h's to cancel out then. So my final answer would just be 2x plus h minus 4. And the difference quotient tends to be an area of struggle for a lot of students. So we're going to do another example when we plug something different into the quotient. So what I want you to understand about the difference quotient is, specifically it's set up in this generic form, an x plus h and an x, but you can add numbers in for those x's or for the h's. So let's do that with this next example. So if I ask you to find the difference quotient of x squared minus 4x plus 7, and now the quotient is in this form, the first thing that you're going to do is you're going to replace the x with an h plus 5. So you've got to do this part first. So let's rewrite all of this as h plus 5 squared, so get rid of that x, minus 4 times h plus 5, and then plus 7. And the second part of it is you have to then subtract f of 5. So you've got to go through and plug 5's in for both of these x's as well. Now before it was just minus f of x and we just used the entire equation that we subtracted. Well, this time we actually have to make a substitution into that equation. So it'd be 5 squared minus 4 times 5 plus 7. Again, input all of that in parentheses because you're subtracting that whole quantity. And then we still would have to divide this by h. So simplifying, you want to FOIL this again. So you're going to end up with an h squared. This is going to be a 5h, and another 5h makes 10h. And then 25. Use the distributive property. Add 7 and subtract this whole entire quantity here. 25 minus 20 plus 7. Again, this is all going to be divided by h. So I think what I'm going to do here is I'm going to combine all of my like terms here to simplify this. So h squared plus 10h plus 25 minus 4h. I'm going to combine these two together. That makes plus 13, minus 13. And combine all of these together. I would get minus 5 plus 7 would make 12. And that's still all divided by h. So now if we combine like terms, start off with the h squared. I don't have any more of those. 10h minus 4h's would make a positive 6h. And 25 minus 13 minus 12 is 0. They cancel each other out. So if we factor out an h in the numerator, the h's in the numerator and the denominator would cancel out and I'd get an h plus 6. That's my final answer.